So in this video, we want to negate and simplify the compound statement P or Q implies R. Now, this is the meat of what you're going to learn, and you have to really learn how to simplify. It's one of the most important things that you need to know because I'm pretty sure that if you don't know it, you'll be wrecked on any exam that you're going to do regarding some introduction to discrete mathematics. So here is how this goes. We have P and Q implies R. So let's just write that down first. So we want to simplify this. Now, simplify this, we're really asking for this compound statement to be logically equivalent to some other statement that will just magically find out in the end. So what we want to do first is to get rid of this implication symbol because implication symbols are really damn hard to work with. So if you see an implication symbol for your first statement, then as soon as possible, get rid of it as soon as possible. So we know how to get rid of this. It's just negated p negated no, it's not that. It's negated p or q or r. Now, how the heck did I get that? Well, remember that P implies Q. That's pretty much logically equivalent, if you remember my last video, to negated P or Q. And that's exactly what happened here. Let's just imagine that P or Q is our P and R is Q. So P implies Q. That pretty much is logically equivalent to negated P or Q um, or R. So that's how we get this statement. These two statements are logically equivalent. Now we have to negate. We simplified the statement, so really it's really simplified and negate, but you can switch them around. So we simplified the statement. Now we want to negate the statements. So when we're working with these statements, we have to work with both sides at once. So when we negate, we're actually negating the statements on the left and on the right. So that's one statement, and we're negating the second statement. So far so good. We simplified the statement to some extent, but not fully, and then we negated it. So that's the first step, and this is the second step. So our third step would probably be to use the Morgan's law and the first substitution rule. So pretty much what we're gonna do is we're gonna expand this, right? That's what we gotta do. So what we're gonna do here in this left side is, well, I really want to get rid of this implication. As I mentioned in the beginning, get rid of any implications you see. It'll probably make your life a heck of a lot easier. So we're negating that or R. So we just negated the left side, and we'll just leave it at that for now. And what we want to do here is we want to use the Morgan's law. And remember what the Morgan's law is. We're just expanding things in. So we're taking this negation and we're timesing it by the inside of these two square brackets. So what we end up with is we end up with two negated symbols, P and Q. And remember I said that the negation of or is and the negation of and is or, right? So this pretty much negating or gives us an and then we get a negated R because we just expanded the negation into the R. So this is by the Morgan's law, and first substitution rule. Now on our last step, on step 4, we're gonna use the law of double negation here. So what we want to do here is we just want to, for the left side, we just want to do what we did in step 3 for the right side. We just want to expand this this negation symbol with the innards. So get that. Or R. So you can really see that what I'm doing here is I'm taking things one step at a time. We don't jump from the start line to the finish line, but we take it one step at a time. So negating in this area would just give us P or Q. And that's all we can do in this side. So there you have it. So from steps 1 to 4, we found that negation of P or Q implies R, which is what we wanted. They want us to negate and simplify this compound statement. So the negation of that is pretty much logic equivalent to P or Q and negated R. So I know it's kind of confusing, but practice makes perfect. So you gotta go through a lot of these questions on your own and try to simplify as many compound statements as you need to understand the process of simplifying statements. But that's it for simplifying statements. Little thing I want to mention before we finish the video is this thing that we have here. I don't even know what it's called, but it's just definitions, and it's not really that important. But I guess I should mention it because I did go through it in class. However, I didn't see it in any exam, so I really don't know the major importance of this. But P and Q are some primitive statements. What we call P implied Q, that's known as the implication. When we flip up, we trade places with Q and P, and we negate both Q and P. That is called the contrapositive. We just trade places. That's called the converse. And when we negate an implication, that's called the inverse. And here are the following truth values for when P and Q is true or false, and the following results, the truth values for the implication, contrapositive, the converse, and the inverse. And yeah, I don't really know what the importance of this is. I'm sure there is importance, but I never really understood what it is, or I was never taught what it is. Well, we went through it briefly in my course, but as I said, it didn't really show up in any exam. So I don't know. Keep this in the back of your minds. Just don't really study much on it because I don't really know what the major importance of it is. But if you really go in depth with all these definitions in class, then I guess you should really learn them. But that's just my opinion. Other than that, please rate, comment, subscribe if you haven't already, and I'll see you guys again next time for another video, which I won't know what we're doing yet. But yeah, look forward to